So hello everybody. Let me give you a very warm welcome to our first online lecture of the Translation Hub Digital Medicine. This is the kick-off of a series of lectures shared by the Translation Hub Digital Medicine. And let me please start with some housekeeping. Please everybody turn off your cameras and microphones. And if you have questions, please post them in the chat window. The lecture will be recorded and will be later published on the BIH website. So we are very happy if you tweet about this event. You see here on the right our Twitter handle, Bell Innovation. And now it is my great pleasure to introduce our speakers for today's lecture. This is Moyez Dharsee, Susan Gilbert Evans, and Van Dong. They all are linked to Indoc Research. This is a not-for-profit company located in Toronto, Canada. Moyez Dharsee is a CTO. Susan Gilbert Evans is Director of Project Management. And Van Dong is Vice President Systems Development. The topic of today's lecture is Health Data Platform Solutions. And I would like to mention that together with Indoc Research and the IT department of the Charité, we are building together a virtual research environment for the BIH community. And this platform does not only offer the possibility to store and share data, but it really provides workbenches and several types of interfaces to interact with the data in the platform. And I'm very happy to now give the floor to Susan, Van, and Moyez.
Thank you, Petra. Okay, well, hello everybody, and it's a pleasure to join you today to present on health data platform solutions. My name is Moyez Dharsee. I'm CTO at Indoc, and I'm joined, as Petra mentioned, by my colleagues Sue and Fan, and we're going to take turns presenting today. Just a little bit about ourselves. We're based in Toronto, in Canada. We're a not-for-profit. We've been around for some time. Originally, we were actually heavily involved in supporting biomarker research in cancer with wet labs, and data was always a big part of our organization. And over time, we gradually shifted over to being a data company. And now we spend most of our time building data platforms to help researchers manage their complex research data. And our goal is really to help researchers share these data through standardized architecture and governance. And so we're going to walk through a few examples of some of the work that we've done and also discuss some general issues related to platforms. So I'm just going to kick it off with an introduction and then I'll pass it over to Sue and Fan to talk about some of the features of these platforms, and then we'll finally wrap it up with some experiences from development of the VRE in terms of sustainable development. So this is kind of stating the obvious, the purpose and the objectives of health data platforms, particularly in the research context. First and foremost, they must protect the rights of the data subjects that are contributing these data. And so the right measures have to be in place in terms of regulatory measures, regulatory rules and compliance. And of course, data platforms increasingly in these times in particular have to support data-driven, integrative, multimodal research. And we're seeing the complexity of data increasing, particularly recently, and platforms just have to be able to support the integration and the diversity of these data. Platforms also have to facilitate the development and use of standards, and that kind of speaks for itself. Importantly, I think platforms need to, of course, support innovation, but they also need to withstand innovation. And just an example that we all know very well, looking at the cost of sequencing a human genome over the last 20 years, how it's decreased significantly. So these things will happen over time. Technologies will evolve in terms of how data are collected, are acquired, and platforms just have to be able to withstand these kinds of innovations. You don't want to have to go and redesign your platform because of these types of innovations that impact research. And therefore, in order to withstand innovation, platforms have to be scalable, and you have to be able to extend these platforms readily, not just as the original developer, but as a community. And of course, interoperability is key. Platforms need to talk to each other, need to be able to connect to other systems. And I think we'll touch on this at the end. Sustainability is so important. So initial funding for platforms eventually runs out or decreases. So how do you keep these platforms going, particularly when they depend on funding? So moving on then, when we talk about data platforms, that could mean different things. We have data repositories of all types. There's the concept of data trusts and data commons. And then there's something a bit more comprehensive, and that's really the focus today, is research data management platforms. And those platforms provide a full suite of data management, analysis, collaboration features that allow researchers to do their work within the platform in a secure way. So that's what we're really going to focus on today. And there are a lot of good evaluations and articles out there, and this one I found particularly interesting. I think it's a good reference for just getting a landscape of different types of platforms, particularly when it comes to the concept of data ownership. This is an issue across domains, not just in health research. So what I'd like to walk you through is some examples, and we don't have enough time to really go through all the great platforms that are out there. There are some very good examples of different kinds of platforms that we all use, but given the time constraint, we're going to limit these examples to just our experience over the years as we've been involved in the development of some of these data platforms. So we'll give you some examples from these different areas: government, hospital environments, and research programs. As we know, there's been an incredible challenge in responding to the current COVID-19 situation, and much of these challenges have to do with just trying to understand the evolution and the impact of the virus. And this has a lot to do with how we manage data, of course. And these are complex data. They're distributed across different environments, and they generally aren't integrated in any way. So this is familiar, I'm sure, to the audience, and it's a familiar story here in Ontario, the need to bring all these data together from different sources. And so we've been involved in the Ontario Health Data Platform from the Ministry of Health here in Ontario, trying to aggregate data from 15 million residents from different sources, from healthcare, from administrative data sources. So that's one example of a platform that we've been working on. And as you can imagine, this is a kind of platform that has to be highly restricted because of the nature of the data, the sensitivity of the data. So we're dealing with a particular kind of architecture here that ensures that ingress or data flowing into the platform and egress at the very end of the workflow are tightly controlled. And so there are measures that are in place to be able to ensure that these data are accessed by only those people that are authorized to access them, that there are appropriate pseudonymization or tokenization pipelines in place, so that before researchers get access to these data, that the data are sufficiently pseudonymized so that the risk to the individual is minimized. So there's a concept of the green room here, which we'll see, I think, repeatedly, which is what we call this a green room because it's a place where you can initially land data with very restricted access to this environment, and only those people that are authorized to see the highly sensitive data can come in and curate these data and prepare them for downstream analysis into a data warehouse or a researcher workspace. And as I said, when data are ready to, when the results are ready to be published or shared outside of this platform, there's a tight request-based egress process to ensure that only the appropriate data are actually exported from the platform. So that's one example. Another one is one that we've been involved in at the McGill University Health Center, which is just down the highway here in Montreal. This is the cardiovascular data platform. There was a need to aggregate data from various sources inside the hospital. Some of these systems may be familiar to you. XNAT was used for capturing acquired imaging data, particularly MR and cardiac MR, and as well as neuroimaging. And REDCap was used for the capture of research clinical assessments. And there were other sources as well, including lab data. And the goal was to aggregate these data within a platform. And these, you can see some of these elements are also recurring across platforms. The concept of a data portal, a data lake, the ability to federate these data and capture the metadata so that you can search and query the data that's been collected. So this was interesting because this was actually a platform that was built not within the hospital. Part of it was some of the environment to aggregate these data was actually located within the hospital, but the rest of it was actually on AWS, on Amazon Web Services. So a public cloud environment, which is actually not something you see very, very often, but it was something that was acceptable in this case because the data were appropriately pseudonymized within the hospital, and then they could be copied over to the public cloud environment. And this shows you the complexity of the actual deployment of the platform. You probably don't need to see all the details, but there's a lot of very cloud-specific technology here that's used to implement this particular platform. So just to give you an idea of a different flavor of a platform in a quite different environment than what we normally see. And finally, an example from a research program, the Ontario Brain Institute is funding a number of research across brain disorders. We've been working with them for quite a few years in developing and operating BrainCode. And BrainCode is a platform that, as I said, is supporting the data management of the funded programs from the Ontario Brain Institute. They include depression, concussion, epilepsy, neurodegeneration, and others. So quite a rich set of data, very deep data on individual patients from many different centers. You can see some of these across the circle here. And a good data set, 20,000 patients, but very rich data on each one of these. And quite complex data as well, not unfamiliar to what is being done here at the Charité. Lots of different modalities and across different diseases. And the goal wasn't just to support any one disease or any one modality, but actually to bring these together and actually to do some interesting comparisons across disorders. So, the obvious complexity of clinical data from different sources, lots of different kinds of imaging, molecular data as well from different modalities, and importantly, identity management, the need to link the data across these different sources. And what was used was actually, in this case, an encrypted health card number, the Ontario health insurance number that each Ontario resident has was encrypted using a homomorphic encryption technique, and that was essentially the pseudonym that is used to identify individuals uniquely and to also link their data. There's a strong emphasis in BrainCode on imaging data, and for those who are familiar with imaging, there's a lot of quality control to be done after the data are acquired, and this is baked into the BrainCode platform to allow things like naming conventions to be maintained in a standard way across all the centers, and there are a dozen different centers contributing MR data into the platform. So it's very important to be able to harmonize across these. Excuse me. And there is also an important emphasis here in BrainCode on data releases. the goal here was to not only allow researchers to process and collaborate on their data while they're doing the research, but eventually to release the data to the community. And so these kinds of interfaces that we're seeing here, these dashboards, were created on the BrainCode portal. So now anybody can come in and request these data. If it's open data, in this case, we're looking at an example of phantom data, you can just go ahead and download it. But there was a real emphasis on making sure that it's easy for researchers across the community to be able to access these data. And so the process for requesting data, especially controlled data sets, like human subject data, it was quite rigorous. So you have to go in and apply, put in your request information, the reason why you need the data. That went through a whole approval process through a data access committee, and finally the data can be shared using tools on the portal. And finally, I want to end with our most active and probably really most interesting project that we're working on in collaboration with Petra and others here at Charité, and that's the Charité Virtual Research Environment. We're going to come back to this at the end, and we're going to reference this over the course of the rest of the presentation. But this is actually a very engaging project. Again, you can see the common elements of a data platform: the need for a research portal, the need for this concept of a green room, and the rest of the platform, which is in the VRE core. And so data flow in either through the portal. You can upload data right there, and this is how data would come in from other institutions, but also data flow in through sources within the hospital at the Charité and the BIH. So, for example, we're currently integrating REDCap and data from the Phoenix packs directly with the VRE, so that these data can flow in and then researchers can deal with them within the platform. Importantly, we're also integrating IT and especially high performance computing infrastructure with the BIH HPC facility. And within the platform, there are a number of features that are available for pseudonymizing the data initially, again, in a restricted access zone, and then for cataloging the data, capturing all the necessary metadata so that you can find the data, you can characterize the data in a standard way. For structured data, there's a data warehouse that allows the data, for example, from REDCap to be ingested into a data warehouse, and that allows you to query these data, but also to create interesting visualizations and dashboards. The most important feature, I think, for now is the analytics environment, and that's what we call the analysis workbench. So researchers can just come in through their web browsers on the portal and access various tools to allow them to access their data and run their pipelines, visualize their data, in some cases access the HPC facilities for computationally intensive operations. And so the workbench is a really important feature, and Jupyter notebooks, for example, are available. You can go in and run your own desktop applications. You can just go to a command line, and a lot of researchers just want a nice, clean Linux environment, a terminal in which they can go in and do what they need to do, install their libraries, install their code, and run their pipelines. And very importantly, over the course of analyzing their data in the workbench, it's important to be able to catalog what they're doing. And the concept of data lineage and provenance is really key to the VRE. So the catalog is available to researchers as they run their analyses and produce outputs. They can link those back into the VRE platform. And so that, again, that allows that lineage to be captured. So I'm gonna now soon pass it over to Sue, because now we're gonna shift over to some of the details about the elements of data platforms that really form the foundation. There's governance and data protection that Sue will cover. Fan will follow with some discussion on the technologies, the software engineering and data engineering technologies that are characteristic of modern platforms, and then we'll wrap it up with some discussion about sustainability. So at this point, I'll pass it over to Sue.
Great. Thank you, Moyez. And thank you again for the opportunity to present today. So one of the key considerations when designing and building a health research data platform is to establish a plan for the platform's governance, security, and operation. And data governance is a process to manage the oversight roles and responsibilities, as well as the data availability, usability, integrity, and security. So we're reminded that the overarching goal of operating a secure research platform is to ensure that the rights of data subjects are protected. In the European Union, the General Data Protection Regulation states that the protection of natural persons in relation to the processing of personal data is a fundamental right. So this must be respected first and foremost. So there are several important points to consider for health research data. First of all, GDPR requirements are based on risk, and personal health data is a special category of personal data that carries a higher risk in processing and therefore needs a high level of protection. And furthermore, data protection must be incorporated by design and by default to ensure the privacy of data. Next slide, please. Another point under consideration for health research data is that some types of these data contain sensitive information that can't be fully pseudonymized or anonymized without losing scientific value. So here's just an example showing that horizontal sections of brain MR images can be assembled together to reveal facial features that together with a photograph could re-identify an individual. But sometimes using the methods to remove these facial features often can cause inadvertent loss of valuable data. So it's important to preserve the integrity of the data while also implementing high security. Next slide. So what's required is an approach for incorporating the oversight, security, privacy, technical, and operational measures into the platform. And this planning should start as early as possible to ensure the platform design reflects these needs. These can be described at a high level by the governance plan. So first, we need to understand the legislative requirements applicable to a data platform's jurisdiction. So this ensures that privacy and data protection can be built into the platform by design and by default. We also need to formulate a governance framework for the operation of the platform. So this is needed to establish the processes and accountability to maximize the data stewardship and data protection while ensuring data are both accessible and secure for scientific purposes. I see in the chat, Cyril, funny to see your face in the presentation. Thanks for adding that. Finally, we need to implement technical and organizational measures for maintaining data security. And this includes documenting the risks and security, policies and procedures, codes of conduct, etc. So next slide, please. It's also important to be aware of the laws applicable to the region where the platform will be deployed. So the governance policy should establish the reference legislative scope. In the case of the VRE, the virtual research environment that we're working on with the BIH Charité team, the applicable laws are GDPR. And in combination, any other applicable national or state laws that could apply. So it's also important to look through these laws to see if there are any other intervening principles or considerations. And I've just included on the bottom another reference example in Canada. Here in Canada, there's a National Electronic Data Privacy Act, PIPEDA, but at the provincial level where we live, the Personal Health Information Protection Act takes precedence. Next slide. So these laws define certain roles and responsibilities, and it's equally important to understand who holds what roles in the platform design. For example, under GDPR, we have the notion of the data subject, the controller, the processor, and a data protection officer. And just for comparison, in Ontario, under PHIPAA, we have a different privacy framework, but the roles and responsibilities do carry some similarities. So it's important to be aware of the data set terms of use and sharing agreements, and to ensure compliance with all applicable laws. Next slide. We can look more closely at the roles and responsibilities under GDPR and how they fit into the platform design. So again, at the heart of the data protection concept is the data subject, whose personal information requires protection at all times. So looking through the circle, we can see the controller is the researcher who determines the means and process of, and purpose of processing. And this individual is entirely responsible for all the processing activities. The processor is the institution that maintains the platform. In this case of the VRE, this would be the Charité. So in this role, they act as a processor on behalf of the data controller because they're providing the data platform. The data protection officer and research ethics boards both have roles in reviewing the ethical and data protection matters for the research project. And of course, we have some non-human roles in here, the data platform itself, which represents the secure storage environment in which the data are held. And we also have on the bottom right the notion of a derivative data sets. Of course, one of the most important features of a data platform is not only the ability to process the data, but to share the data with others so that we can unlock additional scientific value. So data controllers may set out use terms that must be adhered to when the data are passed on to another data controller. So next slide, please. The data controller retains responsibility for the means and purpose of data processing at all times, so and establishes the legal basis of processing. So these responsibilities are described in various data protection documents, agreements, and approvals. So for instance, the data controller must prepare a DPIA, a data protection impact assessment that is assessed by the relevant data protection officer, as well as apply for ethics, evaluation and approval, and enter into a data processing agreement and terms of use with the platform provider. So these are various ways of demonstrating compliance with GDPR. Next slide. And the data protection officer has also an important role in evaluating the privacy and security measures for the data platform itself. So the VRE is currently undergoing a data protection assessment by the DPO and by an external legal team. So this is meant to evaluate the security posture of the platform and ensure that the environment is appropriate and secure and in compliance with GDPR. Next slide. And when data are ready to be shared with others, again, it's necessary to ensure the protection of the data subject is maintained. So we can't just pass on the data to someone else. We must ensure that there are agreements in place and use terms, and these can be used to assist in demonstrating compliance with GDPR. Okay, next slide, please. So the VRE team is currently in the process of developing a governance framework involving an oversight and advisory structure and agreement templates, policies, procedures, as well as a data protection evaluation. So the various committees involved may include advisory, security committees, access committees, as well as a set of templates. And the goal here is to demystify, if you would, the entire process of GDPR compliance for the researchers who are using the platform, and to make sure we have clear, usable templates that can be adjusted and extended to different types of use cases, and again, provide toolkits and tools and resources. The governance framework draws on elements from the Charité policies and procedures that exist right now, also from other platforms that we've been involved with, and others have contributed expertise, including the eBrains platform, as well as the BrainCode platform, which is, as Moyez mentioned, the Ontario Brain Institute's informatics platform. And I've just put a screenshot of a publication that describes the governance policies of BrainCode. And those are set in the backdrop of the Ontario legislation. Okay, next slide. And finally, the technical organizational measures are implemented to ensure a level of security appropriate to the risk. And these are, again, under GDPR requirement. And as mentioned previously, personal data is a special category of data that requires a high level of protection. So examples of such measures include pseudonymization and encryption of data. And in the case of the VRE, the data processing all occurs in the secure firewalls of the Charité. also includes processes to ensure the integrity, resiliency of processing systems, as well as backup and recovery mechanisms, and an overall quality management program. So these are some of the measures that are currently being evaluated by the legal team to ensure that the system can meet all of the requirements under GDPR. And next slide. And so some of the technical and organizational measures applicable to the VRE include the data platform privacy and security measures that are described in a series of documents. So currently we're preparing an authorization concept, description, various risk analysis, etc. And these documents together describe the security posture and the privacy components of the platform. And we also rely on Charité IT, policies and procedures that exist already, and codes of conduct, confidentiality agreements, and training are all additional measures that can be used to demonstrate compliance. So all of these components together are going to formulate the backdrop and make sure that a health data platform is compliant with the laws and provides a secure processing environment. And to expand on the technological approaches in modern data platforms and how some of these components are implemented, I will hand it over to Fan.
Thanks, Shu. Good afternoon, everybody. Glad to have the opportunity to share some thoughts about the development of the platform and also the relevant technologies. So when we are building the data platforms, and some of the development guidelines are always kept in mind. To summarize, they are the agility in data management, self-service, and the robust architecture. So those three aspects work hand in hand to provide the features needed, as well as to support the governance and the policies. As organizations, including research communities, start embracing the big data technologies, we have to deal with the increasing data volume, the variety of the data types, and also the velocity of the data accumulation. So all this add to the complexity of the platform, making both the operational and the technical processes lengthy and slow. Good data platforms, therefore, should first aim to be agile. So the processes in data lifecycle, such as project onboarding, data ingestion, storing, cataloging, curation, should be transparently orchestrated and automated whenever possible to speed up the data provisioning to address the low availability issue that are commonly found in legacy data platforms. The idea of the self-service is that the data platform can be used by a wide range of users for different purposes with the minimal involvement of the IT. The users, including PIs, researchers, and data scientists, they usually have the different data access pattern and will handle the data in totally different ways. So this means the platform should be able to enable the easy data discovery through the use of the context of the data, such as tags, ontology, catalogs, lineage, and versionings, and just to name a few. So this also means the data platform should provide multiple channels for users to manipulate their data or conveniently conduct ad hoc data analysis using the tools of their choice. A good data platform would require a robust architecture that continuously evolves to meet new requirements and also adapt the innovation. The architecture first must be designed in a very flexible way, such that the development path of a platform will not depend on certain technologies and hardware and infrastructure environments. So being flexible will also enforce the development to adopt the industry standard protocols and also the community maintained tools for data exchange. So this not only gives organizations the confidence in their long-term investment because the platform is portable and easily customizable, but also promotes the interoperability and extendability, so which are critical for the platform to sustain. So from the operational standpoint, the architecture must also lay a very strong foundation to scale and withstand failures. Among the modern architecture patterns, the microservice is quite a promising choice for scalable and resilient deployment. So in fact, we have used it in several platform development, including VRE. This architecture consists of a group of loosely coupled services, and each of which lives within its own business boundary. So therefore, they can be restarted, executed, and scaled individually to provide excellent resilience and scalability. So next, we will briefly walk through, next slide, please. Some of the basic building blocks of a data platform and also the common technologies might be considered. So each building block represents a functional group or the layers as part of the data lifecycle. So the technologies involved are the ones we have used in VRE or other works. So also you might have noticed that all technologies listed here, they're open source. So many of them are contributed by the companies such as LinkedIn, Airbnb, and Facebook. The data ingestion layer brings in the data from the various sources to the data lake, depending on the data and your own application. So Apache, NiFi, Kafka are commonly used tools. So once the ingestion is completed, the data will be stored either on the conventional network attached storage or a data lake. The object storage-based data lake solutions, for instance, Minio, support custom metadata encryption and secured API data access. The data lake also tracks the events, including copy, removal, modification, to trigger the downstream processes, for example, cataloging and curation. So cataloging is the process to manage the context of the data for quick data discovery. So the data context includes both the technical metadata, for example, the location of the data, schema, and classification, and also the process metadata, for example, lineage and job execution status. The data catalog is maintained throughout the entire data lifecycle as part of the governance framework. The Apache Atlas is a very powerful tool for this purpose, and also worth to mention that the LinkedIn open source the data hub just last year, which also looks quite promising. The goal of the curation is to ensure the compliance and that the data can be made available with good quality for future use. So this phase may include pseudonymization, data cleansing, transformation, and the data federation. The curated data set often are either loaded into the data warehouse or saved on a storage location different from the raw upload. The platform should integrate the tools to support BI and user-initiated data analysis through the workbench tools and the data manipulation using the SQL query engines. The Apache Superset and Jupyter Hub and Trino are some good tools to consider. So all these function groups mentioned so far should also be presented to the end user in an interactive way, either through the front-end technology or through the open APIs typically organized by an API gateway. So or through the interactive shell or graphic data desktop managed by a remote desktop gateway, for instance, Apache Guacamole. Lastly, operate and monitor groups involve data platform operations and management of the infrastructure. This includes identity management, caching, messaging, log aggregation, system metric collection, etc. In addition, the orchestration systems at the infrastructure level, such as Kubernetes and OpenShift, are essential for stitching together all the layers and the service components through automating the resource management, scaling, and deployment. So in next few slides, I will quickly show some of the concrete example of how those technologies are being used inside the VRE. This is the deployment view of the VRE architecture. We won't have enough time to go through the details on this diagram, but really to show the complexity here. So as mentioned earlier, the VRE adopts the microservice architecture pattern. So the gray gears icon are containerized services, orchestrated by the Kubernetes. So which also manage the network zoning, such as the green room zone and utility zone, as well as the infrastructure resource represented by the blue hexagons at the lower part of this diagram. The system metrics are monitored if utilization of a service goes beyond the threshold, and the Kubernetes will scale up that service. So similarly, if a service goes down, the Kubernetes will try to restart that service. If that fails, the rest of the platform still functions because there's no strong coupling between the different services. So this is basically how the VRE ensures the scalability and the resilience. Next slide, please. So the next slide. So this slide shows the screenshot of the VRE login page and also the project canvas page. So the front end of the VRE is made by the React original open source by Facebook. So most of the pages are made responsive to make sure the best possible user experience across the different devices. Next slide. So in next slide, will show you the example of the data lineage we have talked about. So the VRE uses Apache Atlas to maintain the lineage between the data and its derivatives. So the lineage also tracks the context, such as when and who and where and what actions were performed. The next slide. So I will also show you a screenshot of the Jupyter Hub. So Jupyter Hub is integrated with VRE as part of the Workbench, and which gives the user access to the computational environment and resources without involving the IT efforts at all. So the Workbench tools are deployed on the project basis. So it helps to prevent accidental data access across the projects. In VRE, Jupyter Hub runs on the Kubernetes, so therefore can be very easily horizontally scaled up to support a large number of users. Next slide. The screen posted here shows a different type of a Workbench tool enabled by Apache Guacamole, which fetches the remote desktop into a local browser. So this type of a Workbench allows the VRE users to access the full feature of the Linux station, and including the user-installed applications, the Docker containers, and the graphic interface, and more. So this example was taken from a recent VRE demo in which we used the free server viewer to visualize the output of a containerized defacing pipeline. So next slide. VRE also integrates Apache Superset as a BI tool for data exploration and visualization. So each VRE project has a Superset instance connecting to the project data warehouse and other applicable data sources. The data can be directly uploaded into the Superset as CSV or Excel files, or can be automatically loaded by the ingestion pipelines. So this example shows the RedCap data that being brought into VRE from Charité's HDP database. And Superset also allows the user to use its built-in SQL lab and to query and slice the data for their own needs. So this pretty much wraps up my part of the presentation. I will now hand it back to Moyez.
Thank you, Fan. So we're going to wrap it up with some final remarks, just putting up the VRE conceptual architecture diagram again. All of the elements that Fan just went through are what actually make this platform possible, and essentially power all of these the different components that we're seeing here. You notice that we didn't really, over the course of this presentation so far, we haven't gotten into any domain-specific or research-specific discussions, and that was deliberate because the platform is really built to be agnostic to the kinds of research that are being done for the most part. So there was an initial focus on supporting imaging, radiological imaging based research, and that is reflected in the platform. But really, the way that this is designed, and I think this is how, this is one of the best practices for platform building, is that you build the platform to be able to deal with any kind of data and any kind of research. Obviously, you'll need to build certain pipelines and maybe add some pieces to deal with specific use cases, such as genomics, for example, versus imaging. But the overall foundation and the design of the platform should be agnostic, and that's the way that we've essentially tried to build this. So just a few final remarks. This effort has been quite engaging. We've been at it for about a year. We started in April of 2020, and this slide shows you our roadmap. We've made several releases, roughly on a monthly basis. There's been a release of the VRE. The first one was in September, and we're now pretty much at the end of this particular phase of the development roadmap, which takes us to the end of May, and we are making plans for continuing on into the next phase. But this has actually been an interesting experience. Basically following the agile methodology for software development, and really trying to keep everybody as engaged as possible, and having these quick releases. So the agile development model, basically that we've used has consisted of bi-weekly sprints. So a sprint is basically the development team coming together and working on a particular set of features that are targeted for an upcoming release. And you can have weekly sprints or bi-weekly sprints. In our case, every 2 weeks, we had one of these sprints where everybody just all hands on deck, get the work done, and then release. When our releases, like I said, are roughly on a monthly basis. And there's a real power in doing this, because you can, when you release often, you can get continuous delivery. You can get feedback as soon as you put a new version out there. And it also allows you to reflect and adjust your roadmap along the way. And as everybody knows, nobody really has the full set of requirements. We don't really know what's going to come up down the road, what the needs are going to be for a particular research project or for supporting a particular kind of data. This is just continuously evolving. So it's just impossible to predict what's going to be needed down the road. So this is a very effective model for dealing with change and for being able to adjust the course along the way. And I think another really important part of this experience has been the engagement of the research teams and other members of Charité and BIH in supporting the development of the platform. We've had these weekly meetings which are open to anyone. And if anybody here in the audience at the Charité or BIH wishes to join, please do get in touch. But this has been a way of getting everybody engaged to actually not just get an update on what we're doing from a development perspective, but also to be able to actually interact and influence the development of the platform. Because ultimately, this is made for the research community here at the Charité, and so this has been an interesting kind of observation. Probably not typical when working with, say an organization. When you bring in a typical vendor and that you want them to give you a solution for some informatics needs that you have, often that's not an opportunity that you get. But we find that that's a very effective way of doing this, keeping everybody involved, being transparent. And finally, this really is important from a sustainability perspective as well. And I just want to make some final remarks about the ecosystem development model. We've shown you some examples of platforms that we've been involved with, and there are many other very solid, very well-built health research data platforms out there, and many of them are open source, and they provide their systems for others to be able to use or to deploy. And this is really important. I think for us, this has been a real foundation of the way that we interact with research teams. And the idea is that what you build with one particular platform can be made available to everybody else that you've worked with. So at the bottom here, we're seeing all the different programs that we as Indoc have been involved in. We talked about some of these, like Brain Code and the VRE and McGill, and there are many others. So what we try to do is that we work out an arrangement with any of these partners that what we build for them will be made available to anybody else, and vice versa. So that's what makes this possible, is that when you share, you also can benefit from the work and essentially the funding that other partners put into the architecture. So this is a model that I think is really important from a sustainability perspective. And of course, it's important to build a community around these platforms. So it's one thing to come in and get the initial funding and do the development, but how do you keep maintaining and extending and making sure that the platform remains relevant in years to come? And that's really, that really highlights the importance of having an ecosystem, a set of not only the research teams, but also the development teams. Many times when research programs apply for funding, they have the opportunity to add a line item in their budget to have developers or data scientists funded, and so it's important to engage these people into the development and the ongoing maintenance and extension of the platform. So finally, I'll close it with some acknowledgements. We have a great team at Indoc of people on the development side, on the operations side, on the government side, and they've been just wonderful in the delivery of these platforms, particularly the Charité VRE. And of course, we've really, it's been a pleasure and an honor working with members of the Charité and BIH, Petra Ritter, Peter Brunecker, Paul and Francie, Michael, Georgios, and the rest of the Charité IT team that has supported the platform, as well as the research groups, as I mentioned, that have been engaged on a weekly basis in just helping us steer the ship. And many of them are probably joining us in this presentation here. So really want to acknowledge and send out our appreciations for everybody that's been involved in building this platform. And with that, I'll end it and pass it over back to Petra for discussion.
Thank you very much, Moyez and Sue and Fen, for this really inspiring and excellent presentation. We got a couple of questions in the chat, and I just will read them to you and would like to ask you to address them. Let me find them. There's a long row now. The first one is, if the host institution that provides a VRE to compute is a data processor, what is the legal status of a researcher processing the data under a data processing agreement? And I'm happy to chime in myself because we are working together on this, but so if Sue wants to start, I'm happy to add to this.
Sure. So I think the question was around the role of the researcher if the platform is the processor. So, and Petra, please feel free to chime in after. I'll make it short, but the data processor, the researcher is the data controller. So they determine the means and the purpose of the processing of the data. And they alone are responsible for establishing the lawful basis and describing how they're going to process the data in a data protection impact assessment. The role of the platform and the service provider, such as the Charité, who's hosting the platform environment, is to act as a processor on behalf. So the key here is that the processor on behalf cannot act or perform in any way on the data without the direction of the data controller, who is the researcher. So the researcher is using the tools and the facility, the hosting environment, the storage of the platform, but they are responsible for what they're doing, how they're performing their analysis, and making sure that the data are properly pseudonymized and shared in an appropriate way. And Petra, did you have something to add to that?
I think it was perfect. Thank you very much. The next question goes in the same direction, and forgive me if I stop reading it because it's jumping back and forth. If a new question comes, the older jump up and I cannot see them anymore. So if the platform physically sits within one country, e.g. Germany, but is virtually accessed by collaborators in other countries, e.g. in EU and outside, does the platform need, oops, now jump. Sorry, I have to scroll up. Need to be compliant with legislation in all countries or just the one it is physically located in? Or is it solely up to the collaborators and the other countries to ensure they are compliant with their own legislations when accessing data on the platform?
Okay, I can start with this one, and maybe others, if they have something to add to this. So I think if I understood correctly, the question was about the data, whether the data controller, if they reside outside the processing environment, which laws or how they interpret the laws that are applicable. So the platform itself is designed to meet the requirements and the needs of GDPR, as well being situated in the local member state, needs to comply with any security and data protection laws in that jurisdiction as well. If the data controller is outside of that jurisdiction, then of course they themselves need to look and respect the laws that they as data controllers must abide by. So my understanding is that there's a need to assess the laws in both countries. GDPR, the aim is to make sure, to attempt to make sure that the laws are sufficiently broad that they can be applied across Europe. But of course, we know that there may be cases of data processing occurring in Canada or in the United States, for instance, so entirely outside of the jurisdiction of the EU. So territorial scope is definitely an issue that needs to be addressed, and I think it's a matter of looking at the terms under which the data were collected, whether this is the informed consent of the data subject or data set use terms for shared data, and maybe work together with the data protection officer to determine the correct legal scope and legal purpose.
Thank you very much. Next question goes in a similar direction. If a user downloads data, he/she becomes controller, and thus DPIA needed in addition for sure. If one compute on a platform without downloading data, a user only needs a DPA, and later it's explained. So in this case, data processing agreement, as I understand GDPR.
Okay, so I think the question is asking about if data are processed outside of the platform. In any case, a DPIA is required. Anytime a data controller wishes to process data, if they wish to use the VRE to process that data, the data need to be brought into the VRE. So in that case, before that occurs, then it's necessary to carry out a DPIA. To describe the purpose and means of processing, identify the lawful basis, and identify how you would be, at a high level, how you would be using the VRE to process that data. And then once the data are processed or the results are achieved and the data set is ready to be shared, then it's necessary to formulate some form of demonstration of GDPR compliance when you're passing that data set on to a new controller. So in that case, if the data are going outside the platform, there may be additional protections required, such as encryption. If the user is coming into the platform to process that data set inside the VRE, then a data sharing agreement is required between the two parties. So again, I think it's one of the aims of going through this development process is to try and unravel and unlock and make it a little bit easier to interpret under which circumstances these various DPIAs are required.
Thank you very much. Next question. After processing on a computational platform, results need to be exported. How to ensure only derivatives are exported? Say user makes a copy, it looks like derivatives, but it isn't.
Well, maybe I can say a few words. I mean, this is definitely a challenge in any data platform. How do you actually inspect the data outputs sufficiently to judge whether those data are actual derivative data or contain sensitive information that shouldn't be normally shouldn't be exiting the platform? But I think it really comes down to the kind of platform that you're dealing with. We showed an example of the COVID-19 data platform earlier, and in that environment, it is necessary and it is enforced. The egress of the data or of results rather is highly managed, and that's just because of the sensitive nature of the data and the rules that apply in that particular area. So there's a review process that takes place to actually inspect the contents of what's being requested to be exported from the platform. In the case of other platforms, including the VRE, that isn't something that is technically enforced. However, I mean, so what's in place are agreements, and obviously there are agreements that the user enters into, the researchers agree to, that say that they're not going to do anything nefarious or inappropriate with the data. But generally, the data ingress and the data egress within the platform is the responsibility of the data controller. That is, so they're responsible and therefore they are accountable for what they put into the platform as well as what they pull out of the platform. And that is essentially the mechanism by which we deal with it in the VRE. I don't know if anyone has any other comments.
I think it was perfect. Thank you very much, Moyez. Next question. There are so many. I hope we can manage to get as many as possible in the remaining time, which is actually officially only 1 minute. How is the authentication process being done? Also, is there the possibility of HPC on the platform?
Yeah, I can take on that. So the authentication at the VRE is done using a software tool called Keycloak, and also using the OID's OpenID Connect protocol. And the VRE Keycloak is federated with the Active Directory deployed at Charité. So this is how the authentication is done. And also the HPC, yes, we are actually integrating the HPC deployed at Charité, and the VRE users can access the HPC through one of the workbench tools that we just showed.
Thank you very much, Fan. Next question. For the VRE example, is pseudonymization in the green room as opposed to locally before being uploaded to the platform only feasible if the data source is Charité BIH?
I can jump in here. Sorry, I had an issue with the mute button. The green room is an environment in which pseudonymization and other preparation can be done regardless of what the source of the data are. So in some cases, those data are flowing in, say, from the PACS or from other data sources from the Charité. They land in the green room. In other cases, data are being uploaded by researchers from other institutions. So again, it really comes down to the agreements. If those institutions find it acceptable to transfer data that have not yet been pseudonymized into the VRE, then that's part of the arrangement. And again, as a data controller, they're responsible for that decision. But if that is an acceptable workflow for them, then they can come into the green room and they can also take advantage of the pseudonymization capabilities. And one example of that is actually the Generate network project that's being supported by the VRE. It's actually a project consisting of 80 centers across Germany that are uploading clinical MR data, or that are planning to do so. And so these are MR data sets that may contain sensitive information in the DICOM headers. And what we've set up is a pseudonymization pipeline to be able to mask those field values in the DICOM header with pseudonymized information. So hopefully that addresses the question.
Very well. Thank you very much, Moyez. We take 2 more questions, and I think these are also the last questions that I see right now. Are fair data principles considered in the platform?
Yes, that's a great question, and we didn't speak specifically about the FAIR principles, and that was kind of deliberate because we from our perspective, those data principles, findability, accessibility, interoperability, and reusability are really baked in and really embedded across many levels of the platform. So, and we talked about some of the features such as findability. The data catalog is key to be able to, and the ability to capture metadata, both business level metadata, objective metadata, as well as domain specific annotations and metadata allow you to find the data. And there are many other such examples for the other FAIR principles as well. So, and we'd be happy to get into those details. And probably don't have time today, but we can follow up. Please feel free to follow up with us if you want to know exactly what the details are for how we comply with the other principles.
Thank you very much. And the final question, is there a GitHub, a GitLab repository to track the state of development?
Yes, absolutely. All the VRE source code, as well as the deployment automation scripts, are stored on the Charité GitLab.
Thank you so much, Fen. Let me thank you again for this wonderful presentation. I really enjoyed it, and I hope everybody else also enjoyed it as much as I did. Thank you, Fen, Susan, and Moyez. And thank you everybody for attendance, for the great questions, a good discussion. Our next lecture in this new series will be announced. Please stay tuned, and I wish you to stay healthy and a good remaining day. Bye-bye.